From the dawn of civilization, humanity has gazed upon the heavens with a mixture of awe and apprehension. The weather, in its capricious dance of sun and storm, has held sway over our destinies, shaping the course of agriculture, commerce, and even warfare. Weather modification, in its broadest sense, encompasses any deliberate attempt to alter the natural patterns of the atmosphere. While the concept may seem like the stuff of science fiction, humans have already dipped their toes into the vast ocean of weather control, albeit with mixed results. The allure of weather control is undeniable. Imagine a world where droughts could be extinguished with the flick of a switch, where hurricanes could be steered away from populated coastlines, where the destructive fury of hailstorms could be mitigated before it wreaks havoc upon crops and infrastructure. The promise is tantalizing, but the reality is far more complex. The quest to control the weather is a testament to human ingenuity, but it is also a stark reminder of our interconnectedness with the natural world. The decisions we make today will reverberate for generations to come, shaping not only the weather above, but the very future of life on Earth. Perhaps the most widely known and practiced form of weather modification is cloud seeding, a technique that aims to enhance precipitation by introducing artificial particles into clouds. Cloud seeding seeks to provide a seed around which these microscopic water droplets can coalesce, growing larger and heavier until gravity pulls them down as precipitation. The most common seeding agents are silver iodide and dry ice, both of which promote the formation of ice crystals within clouds. The efficacy of cloud seeding remains a subject of ongoing scientific debate. While there is evidence to suggest that it can increase precipitation under certain atmospheric conditions, the magnitude of the effect is often difficult to quantify. Factors such as cloud type, temperature, wind speed, and the presence of naturally occurring ice nuclei all play a role in determining the success of cloud seeding operations. As with any technology that seeks to manipulate the natural world, a cautious and evidence-based approach is essential. While cloud seeding operates on a relatively localized scale, geoengineering encompasses far more ambitious and controversial proposals for altering Earth's climate system. Geoengineering schemes typically fall into two broad categories: solar radiation management and carbon dioxide removal. Solar radiation management techniques aim to reflect a small percentage of incoming sunlight back into space, thereby reducing the amount of solar energy absorbed by the Earth's surface and lower atmosphere. Proposed solar radiation management methods include injecting sulfate aerosols into the stratosphere, brightening marine clouds to reflect more sunlight, or even deploying giant space mirrors to deflect solar radiation. Carbon dioxide removal techniques focus on removing carbon dioxide, the most significant anthropogenic greenhouse gas, from the atmosphere. Geoengineering, while holding some potential to mitigate climate change, is fraught with risks and uncertainties. Despite the controversies surrounding weather modification, several countries have experimented with these technologies, driven by a desire to secure water resources, mitigate agricultural losses, or protect infrastructure from extreme weather events. Cloud seeding, in particular, has been employed for decades, with varying degrees of success. China, for instance, has invested heavily in cloud seeding programs aiming to alleviate droughts, replenish reservoirs, and even clear the air of pollution. One notable example is China's efforts to ensure clear skies during the 2008 Beijing Olympics. Leading up to the Games, China deployed a vast network of cloud seeding rockets and artillery shells, ready to disperse any rain clouds that threaten to dampen the festivities. In addition to cloud seeding, hail suppression programs are also employed in some regions to protect crops and property from damage. However, the effectiveness of hail suppression remains a subject of debate, and further research is needed to fully understand its impact on hailstorms and the surrounding environment. The quest to control the weather while driven by noble intentions raises profound ethical, environmental, and geopolitical questions. Weather modification technologies hold the potential to alleviate suffering, enhance food security, and protect vulnerable communities from the ravages of extreme weather events. On the other hand, these technologies are not without risks, and their deployment could have unintended consequences that ripple through the delicate web of life on Earth. The potential for conflict over water resources is a particularly pressing concern. In regions already facing water scarcity, the ability to manipulate rainfall patterns could become a source of tension or even conflict between neighboring nations. Moreover, the long-term environmental impacts of weather modification remain poorly understood. International cooperation and transparent governance structures will be essential to ensure that these technologies are used responsibly and for the benefit of all humankind. By embracing a spirit of collaboration, transparency and precaution, we can strive to harness the power of these technologies for good, while safeguarding the health of our planet for generations to come.